Ernest Rutherford had given his structure of atom, known as the Rutherford's model of atom, in which he explained that most of the space in an atom is empty, the entire mass and the positive charge is concentrated in the center of the atom, known as nucleus, and the electrons revolve around the nucleus in this empty space. One of his students was Niels Bohr. He was extremely interested to study the structure of atom. But later on, when he saw the Rutherford's model, he was not convinced. Because according to the laws of physics, if a charged body is in motion, it radiates energy. So if electron, which is negatively charged, it is moving around the nucleus, it continuously loses energy. And therefore, it moves closer and closer to the nucleus. And hence, it should collide with the nucleus. So Rutherford's model was not able to explain the stability of the atom. When Bohr told this to Rutherford, he appreciated his student's work and asked him to study the structure further. So Niels Bohr, a brilliant scientist, gave his atomic model in 1913. Let's see how he explained his model. So according to Niels Bohr's model, the electrons revolve around the nucleus in definite orbits. They revolve in these definite orbits in which they do not radiate energy. So only particular orbits are these paths in which the electrons revolve. So only particular orbits are allowed in which the electrons can revolve without losing energy. So the electrons which are closer to the nucleus, they are attracted towards the nucleus with a greater force, and the electrons which are away from the nucleus in the outer orbits, they are attracted towards the nucleus with a lesser force. And so, if an electron from an orbit closer to the nucleus is to be moved to an outer orbit, it requires energy. So energy is required to move an electron from an orbit which is closer to the nucleus to an orbit which is away from the nucleus. So let's see the points given by Bohr again. So according to Bohr, the electrons revolve around the nucleus in certain fixed orbits. He called these orbits KLMN, that is the orbit which is closest to the nucleus. It is the K shell. The orbits are also known as shells. So it is K shell or K orbit. So the second shell or orbit is the L shell, the third is M, N, and so on. He related the energy of these orbits to their size. So the orbit which is closest to the nucleus, it's smallest in size and therefore it has the lowest energy. The second orbit has a little higher energy as compared to the orbit which is closest, and the outermost orbit, being the longest or the largest orbit, has the highest energy. So that is the highest energy orbit. So we have seen that to move an electron from an orbit which is closer to the nucleus to an outermost orbit or an orbit which is away from the nucleus, energy has to be given to the electron. So energy is always absorbed or emitted when an electron moves from one orbit to another. So only when an electron moves in between these orbits that energy is absorbed or emitted. It does not radiate energy on its own. That is, when it is revolving in a particular orbit, it does not radiate energy. Only when it moves from one orbit to another that it absorbs or radiates energy. According to Bohr's model of atom, which orbit has the minimum energy? So Bohr had marked his orbits as if this is the nucleus. So the first orbit he had named as the K shell, the second was L, and he related the size of the orbit to their energy. So the smallest orbit, which is closest to the nucleus, has minimum energy. So the orbit which has minimum energy is the K orbit or the K shell. So Rutherford's model was not able to explain the stability of the atom. If the electron, which is negatively charged, is moving around the nucleus, it should constantly radiate energy and should collide with the nucleus. So Rutherford's model was not stable, whereas Bohr was able to explain the stability of the atom. According to his model, the electrons revolve in definite orbits in which they revolve without losing energy. Only when they move in between these orbits that they emit or absorb energy. So Bohr was able to explain the stability of atom. Well, scientists put in a lot of effort to give these results, but not always are the efforts appreciated in the beginning. Niels Bohr initially wanted to be a student of J.J. Thomson. He presented his work to J.J. Thomson, but Thomson was not satisfied with his work. So he refused to accept him as a student. Later on, Bohr was able to give his model, the Bohr's atomic model, which we accept today. So even though scientists face a lot of rejection or criticism in the beginning, they continue to work and at times they give brilliant results.